Welcome to Junior High School Math Series. In this video presentation, let us discuss central angle and inscribed angle. Let us begin with some definitions. An arc is a part of a circle. In the figure, we have circle A, ray AB, and ray AC forming angle BAC, since these two rays have common endpoint at point A, which is the center of the circle. Notice that the sides of angle BAC intercepts a part of a circle. We call it arc BC, written as arc BC. Hence, arc BC is an arc of circle A. A central angle is an angle whose vertex is the center of the circle and whose sides contain the radii of the circle. From the figure, we say that angle BAC is a central angle, circle A, since the vertex of angle BAC is the center of the circle, which is point A, and the sides of angle BAC, ray AB, and ray AC contains the radii of circle A, which are segment AB and segment AC. There are three types of arcs. Number one, we have a minor arc. A minor arc is an arc of a circle that is smaller than a semicircle of the circle. In the figure, we have central angle JPE intercepting arc JE of the circle P. Since arc JE is smaller than half of the circle, then we call this a minor arc. Minor arc JE consists of points J and E and all the points of P that are interior of central angle JPE. The major arc. A major arc is an arc of a circle that is greater than a semicircle of the same circle. From the same figure, we have central angle JPE that intercepts arc JE. The other part of the circle, that is arc JQE, is greater than half of the circle or the semicircle of the same circle. Then we call arc JQE as a major arc. Major arc JQE consists of points J and E and all the points of circle P that are exterior of central angle JPE. Next, we have a semicircle. A semicircle is an arc of a circle whose endpoints are endpoints of the diameter of the circle. In the figure, we have circle P with diameter JM, where points J and M are on the circle. We have semicircle JEM or semicircle JQM, consists of endpoints J and M of the diameter JM and all the points of circle P that lie on one side of diameter JM. Let us proceed to some postulates. First, we have the central angle intercepted arc postulate. The measure of a central angle of a circle is equal to the measure of its intercepted arc. In the figure, we have circle P with central angle JPE and minor arc JE. From the statement of the central angle intercepted arc postulate, we say that measure of angle JPE equals the measure of arc JE. Hence, to get the measure of the other part of the circle, that is major arc JQE, we subtract the measure of arc JE from 360 degrees, that is the complete rotation in a circle. Hence, measure of arc JQE is equal to 360 degrees minus the measure of arc JE. Let us have some examples. Given circle O with measure of angle POS equal to 87 degrees, find measure of arc PS. From the central angle intercepted arc postulate, we can get the measure of arc PS since we are given the measure of angle POS as equal to 87. Hence, the measure of arc PS is also 87. Let us have example number 2. Given circle K with measure of angle AKL equal to 112, find the measure of arc AFL. From the central angle intercepted arc postulate, since measure of angle AKL is equal to measure of arc AL, that is equal to 112, we can get the measure of arc AFL by subtracting the measure of arc AL from 360 degrees. That is 360 minus measure of arc AL. Substituting measure of arc AL equals 112, we have 360 minus 112, and that is measure of arc AFL is equal to 248. Next, we have the arc addition postulate. Given point B on arc AC, the measure of arc AC is equal to the measure of arc AB plus the measure of arc BC. Let us have an example. Given the figure on the left, measure of arc BC is equal to 65 and measure of arc CD is equal to 98. Find the measure of arc DAB. We can get the measure of arc DAB by subtracting measure of arc BCD from 360 degrees. From arc addition postulate, measure of arc BCD is equal to measure of arc BC plus the measure of arc CD. And since measure of arc BC is equal to 65 and measure of arc CD is equal to 98, then we have measure of arc BCD equals 65 plus 98, and that is 163. Now we can get the measure of arc DAB if we subtract 163 from 360. Hence, measure of arc DAB is equal to 197. Next, we have this postulate. A diameter divides a circle into two semicircles. In the figure, we have circle P with diameter JM. Hence, diameter JM divides circle P into two semicircles, which are semicircle JM and semicircle JFM. Let us have example number 4. Given the figure on the left, measure of angle JPF is equal to 72. Find the measure of arc JF, the measure of arc JFM, and the measure of arc JMF. From the central angle intercepted arc theorem, since arc JF is the intercepted arc of central angle JPF, then measure of arc JF is also equal to 72 degrees. A diameter divides the circle into two semicircles. Hence, JFM is a semicircle because its endpoints are endpoints of the diameter. So the measure of arc JFM is equal to 180 degrees. We can get the measure of arc JMF, that's JMF, by subtracting the measure of arc JF from 360 degrees. So measure of arc JMF is equal to 360 minus 72. So the measure of arc JMF is equal to 288. Let us have another definition. An inscribed angle in a circle is an angle whose vertex is on the circle and whose sides contain chords of the circle. In the figure, we have circle A, ray DB, endpoint at D and contains point B of the circle. Ray DC with endpoint at D and contains point C of the circle. Notice that ray DB and ray DC form an angle that is angle BDC, since ray DB and ray DC have common endpoint that is point D. And since point D is on the circle, ray DB contains chord DB, ray DC contains chord DC, therefore we say that angle BDC is an inscribed angle in circle A. In the figure, we also have arc BC that is intercepted by the inscribed angle. Then we say that arc BC is the intercepted arc of inscribed angle BDC. This time, let us have some theorems. The inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. In the figure, inscribed angle BDC intercepts arc BC of the circle. Hence, from inscribed angle theorem, measure of angle BDC is equal to 1/2 times the measure of arc BC. The semicircle theorem. An angle inscribed in a semicircle is a right angle. In the figure, JM is a diameter. Angle JFM is an inscribed angle that intercepts semicircle JM. Hence, inscribed angle JFM is inscribed in semicircle JFM. Therefore, we conclude that angle JFM is a right angle and it measures 90 degrees. Let us have some examples. Given circle O with arc RQ equal to 109, find measure of angle RPQ, measure of angle ROQ, measure of angle PRQ. Also, measure of angle PQR. Let us start with letter A. Again, measure of arc RQ is equal to 109, and we're looking for the measure of angle RPQ. From inscribed angle theorem, measure of angle RPQ is equal to 1/2 the measure of its intercepted arc, that is arc RQ. Hence, if measure of arc RQ is equal to 109, then we get 1/2 of 109. So the measure of angle RPQ is equal to 54.5. We proceed to letter B, measure of angle ROQ. Again, the measure of arc RQ is 109, and from the central angle intercepted arc theorem, the measure of angle ROQ, a central angle, is equal to the measure of its intercepted arc, that is measure of arc RQ. Therefore, measure of angle ROQ is equal to 109. Let us have letter C, measure of angle PRQ. We are given measure of RQ is equal to 109. Since measure of arc RQ is equal to 109, we can get measure of arc PQ by subtracting 109 from 180 degrees. Since P and R are endpoints of diameter PR and PQR is a semicircle. Therefore, measure of arc PQ is equal to 71. And since arc PQ is the intercepted arc of inscribed angle PRQ, measure of angle PRQ is equal to 1/2 the measure of arc PQ. Hence, measure of angle PRQ is equal to 1/2 times 71, and that is 35.5. Letter D, measure of angle PQR. Since P and R are endpoints of diameter PR, and angle PQR is inscribed in semicircle PQR, then we say that angle PQR is a right angle. Hence, measure of angle PQR is equal to 90. That is by the definition of a right angle. Describe angles in the same arc theorem. Two or more angles inscribed in the same arc are congruent. In the figure, we have circle P, angle JLM inscribed in arc JLM of circle P, and also angle JFM inscribed in arc JFM of circle P. Since arc JLM and arc JFM are the same in circle P, hence we have angle JLM and angle JFM inscribed in the same arc of the circle. From the inscribed angles in the same arc theorem, we say that angle JLM is congruent to angle JFM. And then by definition of congruent angles, the measure of angle JLM is equal to the measure of angle JFM. Example number 6. Given circle O with measure of angle N equal to 35 degrees. Letter A, find the measure of angle TOR. Angle N is an inscribed angle of circle O that intercepts arc TR. Hence, we have the relationship measure of angle N is equal to 1/2 the measure of arc TR. And since angle N is equal to 35, we have 35 is equal to 1/2 the measure of arc TR. Then measure of arc TR is equal to 70 degrees. And since arc TR is also intercepted by central angle TOR, then the measure of angle TOR is equal to the measure of arc TR, that is equal to 70 degrees. Letter B, find the measure of angle TGR. Since angle N is equal to 35, and notice that angle N is inscribed in arc TNR of circle O. Also, angle TGR is inscribed in the same arc of circle O. Then we say that angle N is congruent to angle TGR. Hence, we say by definition of congruent angles, measure of angle N is equal to the measure of angle TGR, and since measure of angle N is equal to 35, the measure of angle TGR is also 35. That will be all. Thank you for watching. Please subscribe for more math lessons.